Applying similar triangles. So we're going to use similar triangles to find the heights or the distances that are difficult to measure. We're going to work through 4 different examples. Example number 1 says a survey wants to determine the width of a river. She surveys the area and finds the following measures. She uses a pair of similar triangles to help her find the answer. So first of all, we have a diagram. So this diagram is given to us, so we don't have to worry about trying to draw our own diagram for this example. So we need to find the similar triangles. Well, we have this first bigger triangle right here. So here's one of my triangles. And here's the second similar triangle. And we know that they're similar because they share the angle across from each other, and they both have a 90-degree angle, and that means that their other angle must also be the same because all of the angles inside of a triangle add up to 180. So if 2 of the angles are the same, then the third angle will also be the same. So these triangles are similar because of angle, angle, angle. So now what we want to do is we want to assign a variable to determine the distance. So she wants to determine the width of the river. So she's looking for this dimension that's across from the river. So the height of this larger right angle triangle. So this is the dimension that I'm trying to find. So now what I want to do is I want to set up equivalent ratios in order to solve for that unknown value. So remember, when I have similar triangles, my sides are in proportion to each other. So I'm going to set up my ratio so that x is in proportion to the side that would correspond to that in my smaller triangle, which in this case would be 18.6. And then I'm going to set that equal to the 2 other sides that I know the measurements for. So in this larger triangle, I know the base of my triangle is 79.6. And in the smaller triangle, I know the base is 34.2. And from here, I want to use cross multiplication in order to solve for my variable x. So I'm taking 34.2 and I'm timesing that by x, and I'm taking 18.6 and I'm timesing that by 79.6. So I'm going to use my calculator to figure out 18.6 times 79.6, and that gives me a value of 1,480.56. I'm going to keep those 2 decimal places until the final step of my problem. From here, I need to get rid of the coefficient in front of my variable, so I'm going to divide both sides by 34.2 so that they cancel each other out on the left-hand side. And I'm going to do 1,480.56 divided by 34.2. And that gives me an answer of 43.3 if I round up to the nearest tenth. And that is perfectly fine for distances, so side measurements, to round up to the nearest tenth. So 43.3, and what am I measuring in? I'm measuring in meters. So because this is a word problem, I want to have a therefore statement. So therefore, the width of the river is 43.3 meters. Let's do another example. In example number 2, I have a pole that is 3 meters tall, which casts a shadow of 4 meters. And a nearby tree casts a shadow that is 15 meters long. And we want to use this information to figure out what the height of the tree is. So what do I know? Well, I know that they're going to be similar triangles, okay? I can't prove that they're similar triangles, but I'm using the concepts of similar triangles so I know that they are similar triangles. Okay, so normally, again, when we've proved that triangles are similar, we have to use angle, 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 side, 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 or side, angle, side. We can assume that these heights are parallel lines, and therefore we could use some information to figure that out. But you don't necessarily, I'm not going to make you prove that triangles are similar in the word problems. We're just going to always assume that they are. So step number 1, we see these two triangles. So these are the triangles that we're going to use. We're going to assign a variable to represent the height you need to determine. So we need to figure out the height of the tree. So I'm going to call this X. You can call it anything you want, but I'm just going to call it X. And now we're going to set up our equivalent ratios. So my equivalent ratios say that my height of my tree would be in proportion to the height of the pole. So X is over 3. And the length of my shadow of the tree is in proportion to the length of the shadow of the pole. So 15 over 4. And now I'm going to use cross multiplication to solve for my variable X. So 4 times X is equal to 3 times 15. 4 times X is equal to 3 times 15, which is 45. From here, I need to get rid of the coefficient in front of my variable. So I'm dividing both sides by 4. So they cancel out on the left-hand side. So I'm just left with X. And 45 divided by 4 is 11.3 if I round up to the nearest tenth. And what am I measuring in? I'm measuring in meters. So my therefore statement is, therefore, the height of the tree is 11.3 meters. Let's do 2 more examples. So example number 3, a hiker, so here he is right there, or she, his eye level is 2 meters above the ground. They want to find the height of a tree, and so what they do is they place a mirror horizontally on the ground. So there's the mirror right here, which is 20 meters from the base of the tree, and this hiker says that he's going to stand at point C, which is 4 meters from the mirror. And he can see the reflection of the top of the tree in the mirror. So what we want to do is we want to use these similar triangles to figure out how tall the tree is. So we have our 2 triangles. We're going to assume that they're already similar. And we're going to use that information to determine that missing height, which is the height of the tree. So I'm going to call this X. So I could show that it's similar because these 2 little arrow angles here are denoted with the same, it looks like the same symbol, so we can assume that those are the same, and then we can assume that the gentleman and the tree are making 90-degree angles with the ground, and therefore we could have similar triangles based on angle, angle, angle. Again, I'm not going to make you prove that they're similar in a word problem, so just identify where your triangles are, and then identify your variable that you're going to represent, and then use equivalent ratios to set up the with corresponding sides to solve for that missing variable. So the height of the tree will be in proportion to the height of the man, which is 2 meters. So X over 2 is 1 ratio. Then the length of the distance between the tree and the mirror is 20. And the distance between the man and the mirror is 4, so that's my other set of corresponding sides. So now I'm going to use cross multiplication to solve for my variable X. So 4 times X is equal to 2 times 20. And 2 times 20 is 40. From here, I need to isolate my x, so I'm going to divide both sides by the coefficient. So divide both sides by 4, so that the 4's cancel each other out on the left-hand side, because 4 divided by 4 is 1. So x is equal to 40 divided by 4, which is 10. And I'm measuring all of my units in meters. So I can write my therefore statement. So therefore, the height of the tree is 10 meters. Let's do one more example. This time a diagram is not provided to you. So the extra challenge is to figure out how to draw this diagram correctly. So example number 4 says that Sarah needs to measure the height of a flagpole. So we could start by drawing a flagpole. So there's my flagpole right there. And we know that Sarah is 6 feet tall. So let's just draw a stick figure here. This is Sarah. All right, so Sarah is 6 feet tall. She finds that if she stands 12 feet from the base of the flagpole, so this is 12 feet, the top of her head touches the guy wire. So remember, a guy wire is just a wire that we use to keep a thing straight. So we use it, you'll see it sometimes with hydro poles. It's just a tool to help keep an object straight. So there's my guy wire. So when she stands 12 feet, she touches the top of that guy wire. And the guy wire is anchored 15 feet from the base of the pole. So from here, so this entire distance is 15 feet. And that is the information that I have from my diagram. So I have my flagpole, I have Sarah. I know that Sarah's 12 feet from the pole, and the guy wire connects to the base, the ground from the pole at a measurement of 15 feet. So where are my triangles? Well, I have one triangle that is this larger triangle that's made by creating the pole to the guy wire. So that's my one triangle. My other triangle is the triangle that Sarah makes with the guy wire. So right there. So this is where I have those nested triangles. Okay, and I could show that they're similar because we can assume that the pole and Sarah create a 90-degree angle with the ground. And we know that they share this angle in the corner, so that means their third angle is similar as well, or is the same as well. So we know that these triangles are similar. So now we need to figure out, what are we trying to find? So after I've drawn that diagram, what exactly am I looking for? Well, I'm looking for how tall the pole is. So this measurement, so the height of my pole, is going to be my variable x. So I have this diagram now, and now I need to set up my equivalent ratios in order to solve for that missing variable. So I know that the height of my pole is going to be in proportion to the height of Sarah. So x is in proportion to 6. I also know that the length between the pole and the guy wire is going to be in proportion to the distance between Sarah and the guy wire. Well, I know that the total distance between the pole and the guy wire is 15 feet. So that's the measurement that corresponds to x. x. But how do I know how far this distance is right here? Right? Well, if I know that the entire distance is 15, and I know that Sarah is standing 12 feet from the pole, then I can find this missing measurement by taking 15 and subtracting 12. And that gives me a distance of 3 feet. So the measurement of the base of my smaller triangle is 3. And now I'm going to use cross multiplication in order to solve for my missing variable x. So 3 times x is equal to 6 times 15. You can use your calculator to work out 6 times 15, so that gives us a value of 90. From here, I want to divide by the coefficient in front of my variable. So I'm dividing both sides by 3. 3 divided by 3 is 1, so I'm left with 1x, or just x, and 90 divided by 3 is 30. And I know that I am measuring all of my lengths in feet, so it's 30 feet. So now I can write my concluding statement. So therefore, the height of the pole is 30 feet. If you have any questions about this lesson, please reach out to me. Send me an email or sign up for a virtual help session, and I will see you in the next lesson.